Get ready to embark on a thrilling journey through the cosmos as we uncover the mysteries of the newly launched Nancy Grace Roman Space Telescope. Join us as we explore its groundbreaking mission to revolutionize our understanding of the universe. Before we dive into the wonders of this incredible telescope, let's take a moment to appreciate the brilliant minds behind it. This video is brought to you by ScienceScope. Whether you're interested in artificial intelligence, data science, math, or programming, these interactive courses have got you covered. So sit back, relax, and let your curiosity soar with ScienceScope. Now let's turn our attention to the Nancy Grace Roman Space Telescope. This groundbreaking mission is the result of years of hard work and dedication by scientists, engineers, and researchers from around the world. The Nancy Grace Roman Space Telescope, formerly known as the Nancy Grace Roman Telescope or WRST, is an upcoming space telescope currently under development by NASA. Once operational, it will conduct near-infrared and visible light astronomy. It's been described as a wide-field infrared telescope optimized for dark energy and exoplanet research, but also capable of doing cosmology and other science. The telescope is named after Nancy Grace Roman, who was a chief of NASA's Office of Space Science from 1971 to 1979 and played a key role in planning and developing many of NASA's most important missions. After successful completion of its primary mission, Roman will conduct a secondary mission called the Infrared Deep Survey, which will survey more than 100 million galaxies in the near-infrared. Roman has been in development since 2003 and its launch date has slipped several times over the years due to budget and schedule overruns. In September 2020, the total cost of the mission was estimated to be $1.4 billion. The project's development has been marked by setbacks such as the retirement of the first chosen instrument, the Cosmic Background Infrared Telescope, as well as changes in partners and scientific goals. In April 2016, the telescope was renamed the Nancy Grace Roman Telescope in honor of her contributions to NASA and the advancement of women in STEM fields. The Roman telescope is equipped with a 1,600-degree field of view, which is 4 times wider than that of the Hubble telescope. This feature allows the telescope to observe a large area of the sky at once, making it an excellent tool for surveying the cosmos. One of the primary objectives of the Roman telescope is to study dark energy and dark matter, 2 mysterious phenomena that make up a significant portion of the universe. By observing distant supernova, galaxies, and galaxy clusters, the telescope will help scientists better understand the nature of these enigmatic components of the cosmos. In addition to its cosmological studies, the Roman telescope will also conduct exoplanet research, searching for planets outside of our solar system.
The telescope's infrared capabilities allow it to detect the presence of exoplanet by measuring the dimming of starlight as the planets pass in front of their host stars. Furthermore, the Roman telescope will be capable of imaging exoplanet atmospheres, providing valuable insights into their composition and habitability. Another exciting aspect of the Roman telescope is its ability to observe phenomena such as supernova, the formation of planetary systems, and the behavior of black holes. By capturing images of these awe-inspiring events, the telescope will help scientists better understand some of the most extreme and fascinating objects in the universe. One of the things that sets the Roman telescope apart from other space telescopes is its unique instrument suite. The telescope is equipped with a 2.4-meter primary mirror that is made up of 18 hexagonal segments. This large light-collecting area allows the telescope to observe faint objects that are otherwise impossible to detect with ground-based telescopes. The telescope's instruments include a 100-megapixel visible light camera, a near-infrared spectrometer, and a mid-infrared instrument. These instruments are state-of-the-art and were specifically designed for the Roman telescope to carry out its scientific objectives. The Roman telescope is being built by NASA in collaboration with the Space Telescope Science Institute and several universities and private companies. The project is part of NASA's Astrophysics Data Program, which aims to collect data on the universe's dark energy, dark matter, and mysterious substances. The telescope will be housed in a custom-built observatory located at the summit of the Haleakala volcano in Maui, Hawaii. The observatory is being constructed by the University of Hawaii and will feature a 1.4-meter diameter Gregorian telescope. The Roman telescope will have a mass of about 6,600 kilograms 500 pounds and will be equipped with 4 instruments that will enable it to observe the universe in visible and infrared light. The telescope will be launched on a SpaceX Falcon 9 rocket and will be placed into a sun-synchronous orbit about 500 miles or 800 kilometers above Earth's surface. The orbit will be inclined at an angle of 68 degrees with respect to the Earth's equator. This orbit will allow the telescope to observe the entire sky every 6 days while avoiding Earth's atmosphere, which can interfere with astronomical observations. Once in orbit, the telescope will undergo a series of commissioning and testing procedures to ensure that all of its systems are functioning correctly. During this time, the telescope's mirrors will be aligned and the instruments will be calibrated. The commissioning phase is expected to last about 6 months. After the commissioning phase, the Roman telescope will begin its science operations.
The telescope's primary mission will last for 5 years, during which it will conduct surveys of the universe to study dark energy and exoplanet. After the primary mission, the telescope will continue to operate until 2030, conducting a variety of other astronomical observations. The Roman telescope represents a major leap forward in astronomical research. Its unprecedented capabilities will allow scientists to explore the deepest mysteries of the universe and make groundbreaking discoveries about dark energy, dark matter, and exoplanet. As the telescope embarks on its journey to unlock the secrets of the cosmos, we can be sure that it will lead to a new era of discovery and understanding. There are many exciting things to look forward to with the Roman telescope. For example, the telescope will conduct a survey of the universe to measure the rate of the expansion of the universe and study the properties of dark energy. It will also conduct a survey of the Milky Way galaxy to search for planets and other objects in the galaxy. Additionally, the telescope will conduct exoplanet transit spectroscopy to characterize the atmospheres of exoplanet and search for biosignatures. Other exciting observations that the Roman telescope will make include supernova, which are the explosions of stars, gamma-ray bursts, which are the most energetic explosions in the universe, and active black holes, which are black holes that are actively consuming matter. Overall, the Roman telescope is a highly anticipated addition to the world of astronomy. Its launch is a major milestone in our ongoing quest to understand the universe and our place in it. We can be sure that the telescope will make exciting discoveries that will expand our knowledge of the cosmos and inspire future generations of scientists and explorers. So there you have it, folks, a comprehensive guide to the amazing Nancy Grace Roman Space Telescope. If you enjoyed this video, don't forget to hit the like button and subscribe for more updates on all things space exploration. We would love to hear your thoughts and comments down below, so feel free to join the conversation. And if you want to support our channel even further, check out our support page. Your support helps us continue to produce quality content that brings the universe to your fingertips. Thanks for joining us on this journey through the cosmos, and we'll see you next time. Want to learn more about the fascinating topics we explored in today's video? Look no further than the resources we've carefully selected for you. Imagine if someone handed you a brand new pair of glasses that could see much farther than you could with your old ones. You'd probably be able to make out details in the landscape or perhaps see stars more clearly in the night sky. That's just a hint at what astronomers will experience when they first use the Nancy Grace Roman Telescope, scheduled for launch in the mid-2020s. This telescope is NASA's next great observatory, and it's poised to revolutionize our understanding of the cosmos in ways we're only beginning to imagine, so get ready. With the help of this new time machine, we are about to go on a journey through the future of astronomy. This image may look like a pretty typical Hubble Space Telescope photo of a colorful, energetic nebula, but it's actually one of the first science images taken by the Nancy Grace Roman Telescope. It was captured during the commissioning phase of the telescope's construction when engineers were checking out its instruments. While not an official science image, this image still gives us a glimpse of what we can expect from the new observatory. The mission's senior project scientist, Jonathan Gardner, says this image is part of the reason why he and other scientists have been working toward this mission for years. I think this is just the tip of the iceberg, he says. This is the first time that we've had a survey telescope in space with this broad field of view and the sensitivity that Roman has. And so there's really no way to know what we're going to find until we do the survey. So what exactly makes the Roman telescope such a powerful new tool for astronomers? To answer that question, we need to understand a little bit more about the nature of light itself. Visible light is just one tiny slice of the electromagnetic spectrum, which also includes radio waves, microwaves, infrared light, ultraviolet light, and X-rays. Different types of electromagnetic radiation can carry different kinds of information. For example, radio waves reveal the presence of cold gas and dust in space, while ultraviolet light can penetrate through clouds of gas and reveal hot stars that are being born. Telescopes that can detect more kinds of light give scientists a more complete picture of the universe. And the broader the range of wavelengths a telescope can observe, the more information it can gather. Most telescopes focus on a narrow band of wavelengths. For example, Hubble detects primarily visible light and some ultraviolet and near-infrared light. However, the Roman telescope is what's called a multi-wavelength telescope, meaning it can observe a wide swath of the electromagnetic spectrum all at once. In particular, the Roman telescope is designed to detect near-infrared light with wavelengths ranging from 0.6 to 5 microns. One of the most important things the Roman telescope will see is the light from the universe's first galaxies. Most of the universe's starlight is emitted in the infrared because the light has been stretched to longer wavelengths by the expansion of the universe. Unfortunately, Earth's atmosphere also glows in the infrared, making ground-based telescopes in this wavelength range essentially useless. But since the Roman telescope will reside above the atmosphere in space, it will be able to detect the faint infrared glow of distant galaxies without interference. In fact, one of the telescope's main goals is to peer back 13 billion years to detect the first galaxies that formed after the Big Bang. Scientists hope that studying these early galaxies will help them better understand how large-scale structures like galaxy clusters came to form. Another thing the Roman telescope will detect really well is the light from stars that are shrouded in dust. Typically, gas and dust obscure our view of stars that are actively forming. But the Roman telescope's infrared vision will allow it to see right through these clouds and identify stellar nurseries where baby stars are being born. By studying how stars form, astronomers hope to learn more about our own solar system's origins. Astronomers will also use the telescope to study exoplanets, planets outside our solar system that orbit other stars. The transit method, which measures the dimming of starlight as an exoplanet passes between Earth and the star, has proven very effective at discovering thousands of exoplanets. But the Roman telescope will help astronomers gather more information about exoplanets themselves by measuring the atmospheres of some exoplanet with what's called spectroscopy. If an exoplanet's atmosphere contains certain chemical compounds, it may indicate that the planet has a liquid water ocean. Scientists will use the power of the Roman telescope to search for these telltale signs in the atmospheres of exoplanets that have already been discovered. And the Roman telescope's broad field of view means that it will be able to monitor multiple exoplanets at once, allowing scientists to collect valuable data on several worlds simultaneously. But perhaps the most ambitious project the Roman telescope will undertake is mapping the distribution of dark energy in the universe. Dark energy is a mysterious force that makes up roughly 3/4 of the entire universe. Scientists know that it exists because of the effects it has on the expansion of the universe, but they don't know what it is. One leading hypothesis suggests that dark energy is not a constant, but rather varies in strength throughout space. If this is true, then the large-scale structure of the universe may be even more dramatic than we realize. To test this idea, the Roman telescope will measure how well matter and dark energy both clump on the largest scales. The unprecedented power of the Roman telescope will also enable scientists to tackle smaller questions that could have big payoffs. For example, astronomers want to know how many of the roughly 100 billion Earth-like planets in the Milky Way might have the potential to support life. Some scientists believe that conditions suitable for life are probably rare, while others think they might be common. One way it will do this is by detecting water vapor in the atmospheres of planets similar to Earth. Water vapor is an indicator of a liquid water ocean, which could mean the presence of life. The telescope will also detect the presence of oxygen, carbon dioxide, and methane, gases that are unlikely to occur naturally on planets with an atmosphere. While these are just a few of the projects the Roman telescope will take on, it's really meant to be a general-purpose telescope that can be retasked by scientists for decades to come. In fact, scientists expect it to remain operational for at least 10 years, which is double the amount of time Hubble has been operating. That longevity is partly due to the telescope's unique design. The Roman telescope features a 4-meter-wide primary mirror made of beryllium, a lightweight metal capable of holding its shape at low temperatures. Beryllium mirrors are typically used on space telescopes like Hubble, but Hubble's mirror segments are made of glass, which requires them to be supported by a complex arrangement of internal structures. The beryllium mirror on the Roman telescope can be unsupported, which reduces the amount of heat it absorbs from the sun and allows the telescope to operate more efficiently. Additionally, the telescope is equipped with an innovative active cooling system that maintains a temperature of -227 degrees Celsius. This cryogenic temperature slows down the vibrations within the telescope, resulting in sharper images. In order to capture all of this invisible infrared light, the Roman telescope uses a 215-megapixel camera called the near-infrared camera or NIRCam. This camera will enable the telescope to take high-resolution images of the cosmos. And the telescope's second instrument is the near-infrared spectrograph or NIRSpec. This spectrometer will disperse light into its component wavelengths, allowing scientists to analyze the properties of the objects they're observing. All of the Roman telescope's instruments are contained within a single instrument module attached to the telescope's main body, which houses the primary mirror, the secondary mirror, and the telescope's fine steering mirror. While the Roman telescope is expected to last for at least 10 years, astronomers are hopeful that it will continue operating for many more. After all, the universe doesn't stop expanding just because we stop looking. Thanks for watching this episode of SCI Show Space. In 1928, astronomer and science fiction author Robert A. Heinlein wrote, "As we seek the face of the deep, the universe is dimly aware of our scrutiny and may not remain still for as long." And that may be the case for Nancy Grace Roman, but not in the way he imagined. Hi, I'm here for this channel. Nancy Grace Roman died just over a year ago at age 77 after a battle with cancer. But her legacy lives on in the launch of the James Webb Space Telescope, which she helped plan and build for more than a decade. The largest and most powerful space research observatory ever built, Webb will explore the universe as never before. It's already returning amazing images that are revealing new wonders of the cosmos. When Nancy joined NASA in 1960, she was one of the agency's first female engineers. She worked on the Apollo missions to the moon and then transitioned to the Hubble Space Telescope, where she helped solve technical problems, but she wasn't done yet. When NASA announced plans to build an infrared telescope in the early 1990s, Nancy volunteered to lead the project. This became known as Next Generation Space Telescope, or NGST. Later renamed the James Webb Space Telescope in honor of the NASA administrator who championed the project. At first, NGST seemed like a good idea. NASA had just completed construction of the Hubble Space Telescope, which was launched into orbit in 1990. But Hubble had been plagued by problems since its launch. Its mirror was 1.5 meters out of shape, which made it impossible to focus its primary instruments. Engineers on the ground used a set of corrective optics called an optical tube assembly to refocus the telescope. However, this workaround was imperfect and astronomers could only use 2 of Hubble's 3 instruments. In addition, the flawed mirror prevented Hubble from operating in the infrared, limiting its ability to see very distant objects such as galaxies. By contrast, Angst would be much larger than Hubble, with a 6.5-meter mirror that could focus on infrared light. This would allow scientists to see much farther back in time and detect some of the earliest stars and galaxies in the universe. The sheer size of the project was daunting and no one knew if it could actually be pulled off, but Nancy was determined to make it happen. She led a team of engineers and scientists at NASA's Goddard Space Flight Center in Maryland, which was responsible for building the telescope's instruments. Her team also included researchers from universities around the country who were eager to test new technologies. Together they created an innovative design for Angst. It would have a huge mirror made up of 18 smaller hexagonal segments that could move independently. This allowed for a large light-collecting area without the need for a large, heavy mirror. In addition, the telescope would be coated with a multi-layer tennis court-sized sunshield that would keep its scientific instruments cool enough to operate in the infrared. But perhaps the most ambitious part of the design was its proposed launch vehicle, an Ariane 5 rocket. At the time, Ariane 5 was being developed by the European Space Agency and was designed to lift payloads of up to 20 tons into geostationary transfer orbit. This was more than double the capacity of any rocket ever flown. But there was a problem. Ariane 5 was running years behind schedule and there was no guarantee it would ever fly. Undeterred, Nancy and her team pressed on with development of Angst. They built a full-scale prototype of the telescope and tested it in various configurations to make sure it would survive the rigors of launch and deployment. They also worked closely with Arianespace to make sure the telescope could be integrated into the rocket. But as the years went by, it became clear that Ariane 5 was never going to be ready to fly. In fact, the rocket didn't make its first successful launch until 1996, 6 years behind schedule. By that time, Nancy had lost patience with the delays. She decided to press ahead with plans to launch Angst on a smaller rocket called a Delta III. The Delta III was much less powerful than Ariane 5 and could only put about half as much mass into orbit. This meant that the telescope would have to be redesigned to reduce its weight. But Nancy was undeterred. She and her team went back to the drawing board and came up with a new design for Angst. This version of the telescope was much lighter and simpler, but it was also much smaller. Instead of a 6.5-meter mirror, it would have a 4.5-meter mirror and its overall length would be reduced from 53 meters to 22 meters. But even with these changes, Delta III was struggling to lift Angst into orbit. By this time, it was clear that the project was in serious trouble. There was no way it would be able to meet its launch date of 2007, and that led to calls for the entire project to be cancelled. However, Nancy refused to give up. She and her team worked around the clock to get Angst ready for launch. They cut costs wherever they could and they built new instruments that were lighter and simpler. But most importantly, they kept pushing the launch date back. Eventually, they settled on a target launch date of 2018. And finally in 2017, the telescope was ready to fly. It was shipped from Goddard to French Guiana where it was integrated with the Ariane 5 rocket. On December 25, 2021, exactly 31 years after the groundbreaking for the project, Angst, now renamed the James Webb Space Telescope, was launched into orbit. In many ways, James Webb is everything Nancy hoped it would be. It has a huge mirror that collects lots of light. Its instruments are extremely sensitive and its sunshield is big enough to keep them cool. But in one important way, Webb is not what Nancy envisioned. It doesn't fly on Ariane 5. Instead, it hitched a ride on another rocket called a Falcon 9, which is made by a private company called SpaceX. One of the first things Webb will do is search for signs of life on exoplanet. Webb will be able to detect what kinds of light pass through planets' atmospheres, and then scientists can analyze that light to see what part of the spectrum gets blocked, indicating that it was absorbed by a certain chemical. Scientists think that by studying the atmospheres of exoplanet, they may be able to find planets that have the right conditions for life as we know it. And if Webb can find those planets, then maybe someday we'll find life beyond Earth. Webb will also help scientists learn more about the early universe. One of the most exciting things about Webb is is that it will be able to see back to the beginning of time. That's because light takes time to travel. So the farther away an object is, the farther back in time we're seeing it. Webb will be able to see back to about 100 million years after the Big Bang. That will give scientists an unprecedented view of the early universe. They'll be able to see the first galaxies form and evolve. They'll also be able to see the first stars explode as supernova. These explosions are thought to have played a key role in the evolution of the universe. They released the elements that are needed to make planets and life. By studying supernova, Webb will help scientists understand how the universe came to be what it is today. Webb will also help scientists learn more about our own solar system. Webb will be able to observe things in our solar system that we've never seen before. For example, it will be able to see the first images of Pluto and Charon, the dwarf planet that was once considered the 9th planet in the solar system. Webb will also be able to see things in our solar system in a new light. For example, it will be able to see the rings of Saturn in infrared light. That will reveal things about the rings that we've never seen before. The James Webb Space Telescope is a testament to human ingenuity and perseverance. It's the product of decades of hard work by thousands of people. Nancy Grace Roman was one of the key people behind the telescope. She led the development of its instruments and she pushed to keep the project alive when it faced cancellation. When Nancy passed away, she had no idea how amazing Webb would become. But she would have been proud to see how her legacy lives on in the telescope and the discoveries it will make. You can also follow Webb on social media for updates on the latest discoveries. Thank you for watching.